All right, here we are back for just one quick final couple of examples and recap. Make sure, again, you go to your textbook because all the definitions that we've been writing down are in there as well. They don't use the fun for all and there exists, they use the words, but all of the limit definitions for in section 2.4 for right hand, left hand, regular limit and limits that grow without bounds, both positive and negative, are all in there, okay? So just to kind of highlight a couple more functions to think about, right? What is that function? What is that function? Yeah, it's not a great drawing, right? This is an f. This guy, f of x. And we're going to spend a lot more time talking about this a little bit later. But I think I heard some of you. It's the natural log of x, okay? So for right now, we just want to know its basic shape, and we're going to talk a lot about why it is that shape and all those kinds of things a little bit later. But so one of your homework problems in 2.4 is asking you to look at the limit, right, as x goes to 0 from the right of the natural log of x, okay? So by looking at this picture, right, what might be your guess? Good. What's happening here? Our a is 0 on the x-axis, right? I'm interested in looking at going towards 0 from the right. So x is a little bit bigger than 0, and I go to the function and see what happens. I get to that number. And then I approach 0 from the right, and I get x gets closer to 0, and what happened? My number went down, right? And then I get closer to 0, and then my number went down even more. And the closer I get to 0, the more my number goes down, right? And if we could zoom out and have everything all beautiful, right? The closer x gets to 0 from the right, the more the f of x values on the y-axis, right, get more and more and more and more negative, right? So what did we just discover, right? This grows unbounded negative, yeah? Now the problem in section 2.4 helps you try to walk through the idea of relating the n, right, and the delta for this problem, and if you were going to try to do a proof, right? So again, this type of a problem is for every n greater than 0, there exists a delta greater than 0. How do I know it's an n? Because it's a negative infinity, right? How do I know it's a delta? Because x is going to a number, okay? Getting close to some finite number, such that what? If, well, it's a right-hand limit, so what do I know, right? X is bigger than this number and smaller than that number plus delta, right? X is between 0 and delta. 0 plus delta is just delta, right? Then, what is true? My f of x, which is my natural log of x here, right, is smaller than n, right? And n is, oh, sorry, whoops, I wrote n bigger than 0 because usually we're always writing bigger than 0, but for this guy, and some books will choose n to be positive and then write minus n over here. But n is a negative number. The thing about that is when you're playing with these inequalities, if you divided by n, you would need to change the sign of the inequality, right? Because n is, or the direction of the inequality. Because n is a negative number, and if you divide by something negative, right? So if I have the natural log of x is less than n, and I divide by n, but n is negative, right? That would be the natural log of x over n is bigger than 1, right? Okay? Does that make sense? notice the values of the natural log function near 0 are also negative, right? Because they're down here, right? And so if I divide it by natural log of x as well, and that wasn't 0, right? Where is the natural log 0? That's a good thing for you to think about. But if I'm close to, if x is close to 0, then these guys are also negative. So if I divide this guy by natural log of x, then I have to swap the inequality again because I would have that. Yeah, does that make sense? Okay. Now, you wouldn't necessarily want to do that. There's other ways that we would be solving this, okay? This is not the way you would solve it, but I was just distracted by the point that I wanted to make, that if you're doing operations, multiplying or dividing something by n, you got to remember that it is negative, okay? All right, so one of your homework problems tries to help you walk through how that problem plays out when you're trying to use the definition to come up with the relationship now between delta and n, right? So for any n, you can say what delta is in order to be guaranteed to be below that specific negative number, so that that function grows without bound negative as x approaches 0 from the right. That's an important thing that will be useful to us many times. The natural log function has a vertical asymptote at x equals 0, right? So some of the other problems, let's look at, for example, in section 2.2, this is number 37. We've got the limit as x goes, whoops, let me make x look a little bit better. As x goes to pi over 2 from the right of 1 over x times secant of x, okay? So the more you're working with some of these problems, the more we're kind of getting a sense of what causes us trouble and what doesn't cause us trouble, right? If we thought about the domain of this function, 1 over x, right? 1 over x times secant x, well, that might be hard to think about what the graph of 1 over x secant x looks like. We can think about each individual piece, right? 1 over x, that domain, we know like bad things happen when x is 0, right? And now tell me again about secant x. But what do we know about our x? X is going to be close to pi over 2 and a little bit bigger than pi over 2, right? So really that guy isn't causing us any trouble, yeah? And remember, what is secant x? Yeah, good. 1 over cosine x, yeah? So when is secant going to have a problem where secant isn't going to be defined, where secant might have a vertical asymptote, right? Where the values of secant might grow without bound nearby? Well, it's going to be anywhere where cosine x is 0, right? Okay, and where is cosine x 0? Good question, right? Where is cosine x 0? Think about that. I'll leave you there, because that gets us right back to our trig section, our trig appendix that we were talking about, right? Exactly. Good. Nice. Thinking about the unit circle. Very nice. I hear you out there. Cosine is going to be 0 at pi over 2, 3 pi over 2, right? Yeah. Okay. Awesome. All right. So those ideas can help you think about, ooh, do we have a vertical asymptote here? What are we approaching from, right? Is secant positive or negative if x is an angle that's bigger than pi over 2, right? So as far as a unit circle is concerned, if I think about an angle x, yeah, okay, here's pi over 2, an angle of pi over 2 is here, right? And so x is going to go to pi over 2 from the right through angles bigger than pi over 2. And so we're going to be thinking about moving that way. as far as a unit circle is concerned, right? And so what quadrant are we in? We're in quadrant 2, right? For this limit. And then what do you know about the positive or negativeness of cosine, right? And thus secant in quadrant 2, yeah? As far as determining your infinite limit. Does that make sense? That's a little bit of a hint. Okay. This guy obviously going to be positive because x is getting close to pi over 2 and pi over 2 is positive, right? Okay? If this guy is causing blow up, then you got to decide is it positive or negative to determine whether it's unbounded growth positive or unbounded growth negative. Limit heading off to positive infinity, limit heading off to negative infinity. Alrighty then, I think that's about as much videoing as you probably want. Just keep working on problems and thinking about the visuals of what's going on and thinking about relating them to the definitions. And we will continue to proceed in our understanding and discovery and adventure in calculus next when we come back.